normal distribution. If x is a continuous random variable, as you understand, x is a continuous random variable means x takes any value between the given range of variable as normally distributed. First understand what is meant by normally distributed. As you know, normal distributed mean the average of the variables has a large number of frequency, and extreme values of variable takes very less value or less frequency. As you know, the marks obtained in a class for given class test is generally marks are normally distributed. It means the number of students have less mark are very less. Similarly, the number of students have maximum marks are also very less. But generally, average marks student number of students are large. Okay, as here the figure is shown, which is like a bell shape. Remember this shape. We will discuss it later. Now, this normal distribution has mean x bar and standard deviation sigma. Then the normal variable, as we use here normal variable, as this random variable is x is converted into normal variable which is denoted by z, is given by x minus x bar divided by sigma. This normal variable can represented in this graph, as this graph which shows a bell shape, that is normally distributed variable or random variable, and this axis which is a horizontal line is a normal axis on which we have normal variable which is represented by z, as x is a one variable on this bell shaped curve as a random variable. Corresponding x we get value of z, okay, on normal axis by putting perpendicular on normal axis. As we know, mean is the central tendency, that means it occur between the normal variables, between the variables. As this is a normal variable, then x bar is a central value. Now on in this graph, x bar is represented at the on the top of this curve, as x bar the corresponding normal variable is always 0. As you understand, x is equal to x bar, by putting this we get in numerator 0, that means z is a 0. Now we discuss this curve again. Understand, here on a board there are two ways of representing number. As in first case, as we put number 1 2 3 by putting points, these are discrete point. Discrete means in between 1 and 3 there is a 1.2. Now in second case, as you observe here, between 1 and 3 there are infinite number of points, and these points are continuous points. As you understand, we take 2 points very close to each other on this line. If I take these two, then also there are infinite number of values or point between these 2 points. As in first case, these are distinct point, so they are called discrete, and in second case these points are continuous. Okay, so if the outcome of the experiment is a distinct, then the random variable corresponding is called discrete random variable. As we throw dice, we get the value 1 2 3. No, in any case we didn't get the value 2.5, that means we put the dice and we get 2.5. Is that possible? No, we get only value in integer. In other hand, the random variable which has a continuous value, as weight of student in a class. If the range of the student having a weight between 35 to 50, then any value between these is a weight of any student. No one can say that there is a student, all students have a integer value of weight. any student has a value 39.5 kg, or any student has a value 300 gram, or any student has a value 35.100 gram. Yes, maybe occur. That means between 35 and 50, any number can be occur as a variable. So these variables is called continuous variable. Or in first case, as we throw the dice, there is only 6 possibilities of value of variable. But in second case, any value between these two can get as a variable. So this is a continuous variables. So do you understand what do you mean by discrete and continuous? Now normally distributed random variable means what? As we define the bell shape, as you can understand here, the bell shape represented, if I put a horizontal line, then the height between the point on the curve and this axis is varies. Okay, actually these height represented number of variables in distribution. As I put here x1, then x1 on distribution occur in the height of this line. x2 is here, then the height of the line represented the number of variables occur in a distribution. As you understand here, the value of number of x1 in a distribution are less than number of x2s in a distribution. As put I here x3, then you can say x3 are more than x2. Similarly we get here x4, x5, x6, x7. Now in this distribution there are 7 variables which have x1, x2, x3, x4, x5, x6, x7. Now you can compare in between x3 and x4, the height is almost similar, but between x3 and x5 the height of x3 is more than x5. That means number of x3 in a distribution are more than number of x5s in a distribution. Now between x3 and x5 and x7 you can say x number of variable x5 occurs in a distribution is more than number of x7 occurs in a distribution. As you can understand here, these are the continuous values and these are increasing. x1 is less than, x2 less than, x3 less than, x4 less than, x5, as they are on right hand side. As we know, x on right hand side increases, but the number of variables x1 and x7 which are extreme, that means x1 is a very small, x7 is a very large, are less in number, have very less occurrence in a distribution as the height suggested. But as x4, x3 which are middle of the distribution occurs more times as than the extreme value. As you can understand, this is the average. Generally x bar central value is called x mean of distribution. Now x bar is here which occurs maximum time, so the maximum height on between the curve and the axis is represented by curve by x bar. Okay, now as you know, this is called normal curve. As a normal curve has a normal point, normal variable represented by z, and relation between z and x is given by, that is random variable is given by x minus x bar divided by sigma. Now corresponding x1 you get z1, x2 you get z2, x3 you get z3. For each point on a normal on this curve you get normal variables. Okay, by using the relations, so you can evaluate normal variable for any random variable. Normal distribution we use this figure. This is a curve which is a bell shape, and this is an axis which is a normal axis. Now as we understand, the maximum height on the curve, the maximum height between curve and the axis is a represented point on a curve by x bar. and corresponding normal variable is always 0. Okay, so remember this. Now as x is a variable on this curve which is here, then corresponding we get value of z by using relation z is equal to again x minus x bar, that is average of the or mean of the distribution, divided by sigma is called standard deviation. Now we want to find probability of distribution. Probability is nothing but area S. You understand this, as a probability is always 1. Similarly, the area is here between this normal curve, this bell-shaped curve, and the normal axis is a 1. And using this, the area between the axis and the curve is a 1. We can define the probability here. Okay, in normal distribution, as this is a curve on which random variables are given which are continuous. Now if x is a random variable on the axis, then on the curve, then corresponding normal variable on the axis is a z, which is evaluated by again by using formula x minus x bar divided by sigma. Now the area which is here which I shaded is represented as the maximum is represented by here the number of variables which has value less than x. Okay, and on right hand side of this line the area is represented as number of variables in a distribution having the value more than x. Okay, so using this we can define probability distribution here. As this is a symmetric curve, always remember as area, total area is a 1. So on left hand side of this z is equal to 0, that means here the area is a 0.5. Similarly on right hand side from here the area is also 0.5 and total area is always 1. It means x bar is a average which is a random variable as it appear in center, then number of variables less than x bar is equal to number of variables more than x bar. Do you understand? That means half of the variables are less than x bar and half of the variables are more than x bar, as in normal distribution appears.